do a Secchi reading. It gives you an idea of the amount of material that obstructs light in the lake. It gives you a sense of that by the depth at which this disappears. So what you do is you lower it down till the disc actually disappears from sight, and then you raise it back up till it very faintly starts to show itself. So that's a device that's been used for well over a century, probably for 150 years. It's very simple, but it actually gives you a very accurate measurement of a property of the lake. So we can let it lower it down. This rope's graduated in tenths of a meter. We can still see it without right now, but now it's starting to get a little faded. So we use a viewing device, which is a process that eliminates light scatter off the surface of the water. Otherwise you would get a false reading. I don't see that disc at the moment if I look through the surface, but with the bucket, let's see how farther down it will go. I'm raising it up, and there I can start to see the disc. So right there it disappears. On a nice calm day like today, you can just pinch that off. 1, 2, 3, 4, 5, 6, 7, 8, 0.8 centimeters, plus 1, 2, 3, and 4.8 meters is the depth. So that's when the light disappears, or where the disc disappears. It's not the depth that the light penetrates to. The light will penetrate to double that value, because you have to remember the light that we're seeing with our eye has to travel all the way back to the surface. So it makes a double trip for the depth. So people sometimes forget that. So at 4.8 meters, basically it means the entire lake, no matter where you go, is being illuminated by sunlight, which means it allows for the lake to be very productive. And this is a productive lake because when you look at the disc as it settles through the water column, you actually can see little particulate matter obstructing the vision. Your vision, so you can actually see it happen.
I'm holding up here a map of White Lake. White Lake Village is at the very top here at the north end of the lake. You can see that I have marked off 7 sites that we visit every 2 weeks to either take water samples or other measurements. And the reason why we have sites all over the lake is because the lake isn't actually one lake, it's more like 5 lakes. When we look at the chemistry of the lake, we can actually divide the lake into these areas that we have here. The main water body, which is the southern part of the lake, contains about 80% of the water in White Lake. So the upper part here, these 4 sections here, are very, very shallow, from 1.5 to perhaps 2.5 meters, nothing more. So these areas behave very differently from one another, and that's why it's important for us to sample in all of these areas and to interpret these areas separately. I will be taking a temperature measurement of the lake. We lower the thermometer down to the Secchi depth that was just read by Dave.
4.8 meters.
4.8 meters. And we leave it there for 4 or 5 minutes to equilibrate and come to temperature. In the meantime, we take a water sample for total phosphorus analysis. Now the sample bottles and the sample procedure and everything that we use for taking samples for phosphorus, and in this little vial for calcium and chloride, comes from the Lake Partner Program, which is a program that's co-managed by the Ministry of the Environment and FOCA, the Federation of Ontario Cottage Associations. So they provide us with everything that we need for taking the sample, the filter, the 2 sample bottles for phosphorus, which are duplicates of one another, and also the shipping boxes and the labels. So throughout Ontario, this program collects data from about 500 lakes through 800 volunteers that do this every year. So we've been doing this for 9 years now. The sample that we retrieve is again taken at the Secchi depth, where we just drop a bottle, a weighted bottle down, and we wait until it's full, and it's brought back up, and we take samples of the water this way. These are sample bottles that are already cleaned, but we need to rinse them out. This filter contains an 80 micron filter to remove large particles. So we filter some water and we actually rinse out the vial 3 times to avoid contamination. At one point we fill the bottle to the designated line, and then it's capped. Here it is. And this is what we send back to the Lake Partners program. The lab is in Dorset, Ontario, near Algonquin Park, and you can see that on the vial we have information about the actual station, the lake that we're on, and the date. So they know exactly where the sample was taken from and at what time and at what place. So now it's time to bring up the thermometer. And there we can read the temperature. It's 22 degrees exactly. Now, these thermometers are ordinary pool thermometers, but this one I have calibrated against a mercury thermometer that I have, which is a secondary standard thermometer, which tells me that this is the correct temperature.
So we mentioned the Secchi depth being obstructed by cestin and whatnot in the water column, limiting the light penetration. A lot of it is plankton, and Conrad mentioned the filter that was used with the Lake Partners program to collect the sample for phosphorus is an 80 micron filter, which prevents that cestin getting into the sample container. Here we actually want to sample for the cestin to see actually what it's composed of. This is not actually part of the Lake Partners program, it's a White Lake environmental program. So we've got a student grade plankton net. It's very simple, with an 80 micron filter net, and we have a bottle at the bottom, and I'll explain why I've weighted it. It's actually the bottle is charged with water in it. The reason being we want the net to slowly sink through the water column to the Secchi depth. And I can actually follow it with my eye in the water column, and here we're coming up to 4 meters. That's 4 meters. So 4.8 will be just about right. So now the net's hanging vertical in the water column, and we gently bring it up. And now we're sampling the content of what's in that 4.8 meters. Now the trick is, what do you do with it when you get to the top? You can actually see a change of shade You can see color, a slight coloration there. That's our algae and our plankton. The bottle's clear because it's actually blocking the flow of water. So what we do is we actually ventilate the bottle while we keep the net clear, free of the surface, and allow the water to go back through the net. So we're actually retaining the content while we empty this bottle. And you'll see why we're doing that in a minute. Now the bottle's empty. We seal it back off, and now we're going to rinse the content in the net down near the throat of the net. And now if we just raise it up, we can harvest the content. We've now concentrated. That line there is 30 milliliters, and we're right on it. And you can see the density of that. If you want to test to see if you've actually got that sample well collected, you can sample again and look at the bottle, see how empty it is. If it doesn't concentrate, you know you've got all you need. So with that sample, what we do is we decant it into a small sample container like that. And that allows us to put them, what do you call these again, Conrad? These little tubes.
Centrifuge tubes.
Centrifuge tubes. And we can pour the content into them. A lot of stuff in this water column. There's one. And it's not breathing right. There we go. Come on. Come on. Almost exactly what we had. So there we've got the content. Not quite a perfect 30 milliliters, but it looks like about 28. So we've got it all concentrated. We've reduced the volume of plankton that's in 4.8 meters of water into a volume of 30 milliliters. And by the time we get home, this will have started to settle into the tapered bottom here. It won't get any more than about that full of plankton. And based upon that, we will then, after it settles, we'll be able to do an examination under a microscope, and I'll be able to tell you what it is that's obscuring the light in the lake. So in this tube, you can see at the bottom lots of motion, because not only have we collected phytoplankton, which is still settling in the bottom, you see there's a large number of organisms, crustaceans such as Daphnia, calanoids, rotifera, things like that, that are feeding on the algae or on each other. It's very active. I don't know if the pictures will show it, but you can actually see it jumping around down there.
Okay, I have here a number of copies of environment bulletins that we write once a month. And these are meant to be read by people who don't necessarily have a scientific background. Here's one on the White Lake Fen. This is, there are two areas that are fens on White Lake, and they actually contain an endangered species, the bog-bean buck moth. In this one, entitled "It's Our Fault," here we have a discussion of the geological faults that run through White Lake, in fact, that in fact define its shape, and how these faults have occurred, and how we can actually see where the fault lies from the cliffs on the islands along the lake. Here's another one on glacial erratics, and these are these big rocks that you find throughout the forests around the lake, and these were left behind by the glaciers. They're called erratics because they're rocks that actually don't belong here. They come from somewhere else or transported by the glaciers. Here's one which was very much appreciated, is White Lake, What's in a Name? It actually discusses the origin of the name White Lake, why it's called White Lake. There's a lot of people around have different theories. but we've assembled here all of the historical information. White Lake myths and maps. This is another point of discussion that a lot of the locals talk about the lake being a series of 3 ponds or just a stream before the dam was built, and this using in fact very old maps going back to 1822, we can actually show how the shape of the lake has not changed at all with the dam and why. The lake was really never a series of 3 ponds. And this final one here is a discussion of water levels, just how they're maintained, where they're maintained, and the schedule that is used by the operator to try to keep water levels at certain depths throughout the year. So these environment bulletins are all available on our website, wlpp.ca. And that's the White Lake Science and Information website.